All right, in the slope-intercept form of an equation, that's what we're going to be talking about today. So when we talk about linear equations, our standard form is that ax plus by is equal to c, where a, b, and c are real numbers. And that is the standard form. So it would look something like 2x plus 3y is equal to 12. So the a would represent the 2, the b would represent the 3, and the c would represent the 12. And so that's what we call standard form. And when a linear equation is in that form, it's really easy to search for the intercepts. And when we talk about our intercepts, we're talking about the points where they cross the y-axis and where it crosses the x-axis. So the y-intercept is the point where that line, that linear equation, crosses the y-axis. And same thing for the x-intercept. Where it crosses the x-axis. Okay, so just remember, if we have a graph or a coordinate grid, right, and we talk about the y-intercept, well, that y-intercept is this point where it crosses this y-axis. Where does that line cross it? And so just remember, if any point along this y-axis has an x value of 0. So, like, for example, if that's at 2, then that ordered pair is 0, 2. So the y-axis is where x is always 0. So keep that in mind. Now, when we talk about the x-axis, that means the point where this line, whatever line it is that we're graphing, is crossing the x-axis. So any point along here, you know, if we decide it's going to be this point right here, that is at 4, 0 if we gave that ordered pair. So that's where y is equal to 0. So any point along this line, y is equal to 0. Any point along the y-axis, x is equal to 0. So if we just drew a line between those two, let's just say that this was the line that we were looking at, these 2 points would be the intercepts for that. Okay, so it's really easy to figure these intercepts or compute them if an equation is in standard form, and we're going to see how to do that. So let's say that we have an equation 3x plus 5y is equal to 15. And we are told to find the intercepts. Okay. Well, we know that our x-intercept, and I'm going to make a little t-chart here maybe. Our x-intercept is where y is equal to 0. Well, if we know one of these variables in our equation is equal to 0, then we can set that variable to 0. So we have 3x plus 5 times a y, which is 0, is equal to 15. Well, anything times 0 is 0, so we're left with 3x is equal to 15, and divide by 3. So the x-intercept is at 5. Well, remember that ordered pair is where y is equal to 0. So you've got x is 5, y is 0. So that first intercept is at 5, 0. And that's our x-intercept. So then for the y-intercept, remember if it crosses that y-axis, anywhere that line crosses that y-axis is where x is equal to 0. So we can take that same equation and set x equal to 0 in that equation, and then solve for y. Well, anything times 0 is 0, so we're just left with the 5y is equal to 15. So divide both sides by 5, solving for the y, and y is 3. Well, remember that ordered pair then is 0, 3, and that is your y-intercept. So we could easily go graph this just by plotting those 2 points and drawing a line between them. All right, let's do one more example like that. Okay, we're going to find our intercepts again. So remember, x-intercept is where y is equal to 0. So take that equation and set y equal to 0. And remember that ordered pair, you're looking for 2 ordered pairs, is the first one. So this is at 4, 0. X is 4, y is 0. Your y-intercept is where x is equal to 0. So take that same equation and set x equal to 0. And that just leaves us with negative 2y is equal to 12. Divide both sides by your negative 2. So y would be negative 6. So my y-intercept is where x is 0, y is at negative 6. And so then if you had to go graph that, we could easily come and graph this. Let's assume all these are 1 unit. And we're going to go plot these 2 points. So 4, 0 is 1, 2, 3, right here. That's at 4, 0. And then our other intercept is at 0, negative 6. And that would be right here. So 0, negative 6. And then you're just going to draw a line connecting the two. And that would be the intercepts, graphing that equation based on those intercepts. Okay, so hopefully we sort of understand that. Now another way to graph some of these equations is to put them in slope-intercept form. And that form is the y equals mx plus b. Well, remember, m usually stands for our slope. So this, putting it in this format, if you solve the equation for y, then this easily tells us what our slope is. The b term here automatically tells us what our y-intercept is. And that makes sense because look at this equation. If we set this x equal to 0, then this part, the mx part, would be 0. So y would just be equal to b. So the y-intercept would be wherever that b is, and x would be 0. Okay, so really we need to practice being able to solve some of these equations for y. And remember, we want to get y by itself. We want it to look like this with the x first and then the whole number last. And so first, let's just look at an equation. If we have y is equal to 3x minus 5. Okay, what is the slope of this line? Well, if you're in that same format, y is equal to mx plus b, the m in this equation is 3. So we have a slope of 3. And then the y-intercept is at -5. And remember, if we know this information, we could easily go graph that. We have a y-intercept, and this is going to be sort of a sloppy graph, but hopefully you'll see. The y-intercept, we can start at -5. And we know that that point is on our line because it's a y-intercept. Then we have a slope of 3. And remember, slope is just rise over run. Any whole number is always just over 1. So if we rise up 3 units, run over 1 unit, and you keep going, then there's different points on our line, and we can draw a line between the points that we created. And there's the line of that equation. Okay, so sort of putting all this together by being able to solve for some of these, let's just look at some more. What if we have 2x plus 5y is equal to 10? Okay, we're going to put it in y equals mx plus b format. So it might say put in slope-intercept form. Well, we want this y all by itself. So the first thing we're going to do is take the 2x and put it over there. So remember, you can only add and subtract like terms in a whole 10 and then a -2x. They are not like terms. So you want to list them separately. Then we have to divide by 5 because we don't want to know what 5y is. We want to just know what y is. So y is, and remember, we love fractions, so don't give us decimals there, -2/5 x plus 10 divided by 5 is 2. So in this instance, can you tell me what the slope is? That's right, it's -2/5. What's our y-intercept? Is at 2. Okay, good job. Let's do one more example. And hopefully we'll be getting the hang of this some. Let's say -4x minus 3y is equal to 12. Okay, well in this instance, in order to move this 4x over, well he is negative on this side, so we want to add him on this side. Remember, you can only add and subtract like terms. So those get listed separately because they are not like terms. Then we have to divide everything by a -3. So that makes y is equal to -4/3 x. And then 12 divided by -3 is -4. So what's the slope of this one? -4/3. That's right. What's the y-intercept? Is at -4. All right, good job. Hopefully you'll get some more practice putting these equations in slope-intercept form, solving for their intercepts, and hopefully that's good and clear.